This is question 47 from section B of the 2018 PBSAA paper.
In this question, we're told about a family tree, which represents a family affected by a dominant genetic condition. And we're told that all people carrying the mutation show symptoms of the condition, which is just another way of saying it's a dominant condition, because if you have the allele, you express it. Here's the family tree. So we have no one in the family tree affected apart from individual R. And it's worth noting that individual R has no ancestors who has the condition. So it appears to be a novel mutation or a novel event affecting individual R. And the reason why I said mutation is that that's likely the basis for it, because it can't be hereditary, because if it was hereditary, then the person who carried that gene would express it. Unless, of course, it was a mutation in the germline cells, that being a mutation in the sperm cells or the ova of the parents, and then that could lead to the offspring having the mutation. So we're asked to work out which of these statements could explain the presence of the condition in R. So we've already discussed this a bit, but let's go through our statements. Firstly, the mutation occurs in individual P, so that's the mother in this case. So in the development of her ovum, of her egg cell, which would go on to combine with Q's sperm to produce individual R, if there was a mutation, then that would form part of the DNA in the zygote, that would form the embryo, that would form individual R. So germline mutations like that can lead to hereditary genetic conditions. So we can say that's correct because it could be a germline mutation. Moving on, the mutation occurs in Q's father. Well, if it was a mutation in Q's father, then it would affect one of the offspring of, well, it would affect Q, wouldn't it? Because it's a dominant condition. But also, that would have no bearing on individual R, given that Q appears to have not inherited anything from his father, because he doesn't carry the mutation. Thirdly, the mutation occurs in individual R. Now, I did say that the only way in which you could get those kinds of mutations would be germline, because then you end up with a zygote, which then replicates, and then every cell in the embryo's body would carry this mutated allele, this allele which causes the condition. However, if the mutation occurs in the allele itself, or rather if it occurs in the early embryo itself, rather than in the germline of the parent, it can also go on to affect the germ cells, the cells that will go on to form either the testes or the ovary, and then you can end up with a hereditary pattern within the family tree. So the mutation can either occur in the parental germline, in their sperm cells or ovary cells, or in the very early embryo, because then those cells could be part of the germ cells that R will go on to produce. So we need to know the distinction between germline mutations like this, or somatic mutations, mutations that occur within the human body, things like cancer, which are not hereditary. So our answer is going to be that 1 and 3 are correct, which is option F.